Hello, everyone, and welcome back to Engineering 101. On this episode, we will be talking about a subject that we are experiencing in our day to day life, but it's never something that actually crossed our mind before. I have with me today Thomas. Hi, Thomas, how are you?
Thanks, I'm fine.
So, Thomas, imagine we live in a large building, and this building has 20 apartments, okay?
Yeah,
And in this 20 apartment building, people are using the water constantly, all the time, nonstop. Even though the water is being used all the time, the tank is never empty, the water pressure is never changed. How come the water doesn't change even though it's being used all the time? Does the tank know how many tabs are open, or how is this done?
no, in this case, the system must replace the water what is taken out by the customer. And this is the most question
Yeah.
we have to deal with. So in this case, now we have constant water drain, so
Yeah.
we are using constantly water. And we can see this on a constant level here in the tank.
Okay.
In this case, there's always filled water into the tank again, and the filled in water is
being
equal
used to the water being used. Oh, okay.
the water which is going out or taking out of the tank. So then we have a stable state. So now we can simulate if more customers are using more water.
Okay.
So in this case, I will do this. And you see, the water level is dropping down.
Okay. But then, does it reach a place where it's stable, or?
Yeah, it will. So this takes a time. So the stable state will be if the inlet flow is equal to the outlet flow.
So people are using same.
So
as
now
people.
you can see it's dropping and dropping and dropping. And after a time, we have reached a stable state. So
Yeah.
now we are more or less next to this area where we do have this stable state. So now, or it takes some time because it's a big tank.
Yes. Yeah. Now
So
we
now
are
it's stable.
Okay.
And now the inlet flow is equal to the outlet flow.
Okay.
But you can see the level is lower.
Lower. Yeah. And that affects if there's less. The water flow is less, then the pressure is not as.
Yeah,
as
the
much.
pressure is dropping, of
Yes,
course.
yes.
Yeah, so in this case now, if less people use water, then of course the water level will rise again, as you can see it here now, and it's coming up to the steady state like before.
Okay.
Yeah, so now you can see, and it will be stable if the water inlet is equal
Similar
to the
outlet. Okay.
not similar, equal to.
Okay. So it has to be exactly the same.
Yeah,
Okay.
yeah. So it has to be the same water inlet and outlet.
Okay.
Yeah, so it must be equal.
So it doesn't matter how many taps are open. It's just the level, if the level is changing or not.
Yeah, but in this case, we do not want to have the water level changing between 80 down to 30%, for example. So in this case, this means that we are always having also differences on the pressure in the pipe, or when I take a shower, for example. So this I do not want to have. So in this case, we have to put some control engineering on this level control.
Okay. So we have to set a point where the water has to be in at all time. Doesn't go
so
below.
in this case, for example, I take always the water level to a set point, reference variable at 80%. So the tank must be always filled at 80% if there is no water consumption, less water consumption, high water consumption,
Doesn't
and
change.
so on. So the water level always should
to
be
stay at 80%.
at a stable state, in this case 80%, for
Okay.
example.
Yeah. Okay.
Yeah. So in this case, I do this. Now we are working with level control in a control mode, and the level is always stable.
Yeah.
And in this case, we have the same inlet flow as
And
the outlet flow.
flow.
Inlet and outlet flow are equal. So
Okay.
what will happen if we do have more water consumption by the customers? So I can simulate this as well. You see, it's dropping down a little bit,
Oh.
and
then it goes
then
back
of
up
course
again.
it's coming
Wow,
up to
okay.
80% again.
Okay.
And
okay.
this is the reason why we still have more or less the same pressure.
So it doesn't, it goes, if it goes down, the sensor is like, okay, the water is not at the level, go back up, go back up.
Yeah.
Okay.
So then the level drops down, and then of course more level water is coming into my tank, and always reaching 80%, more or less. Yeah, it can be a little bit more and less, but it's very close to 80%.
Okay.
Yeah, and what will happen if we have less consumption of the water?
Yeah.
So
If
this
what
we
people
can do
uses.
here as well.
Yeah.
Let's see. Of course, the water level is coming up,
And then it's going to go
and
down.
then still going down, because at the end, when
We
the
passed the
control is
80%.
stable, the level is stable, and then we are still working at a level
So
at 80%.
even if they don't use water, then less water is going to come in and we're still going to stay in 80%.
Yeah.
Okay.
So we do not have an overshot
Or an undershot.
in the tank or an undershot. So undershot means that there is no
It's
water
not,
available.
We wouldn't, the tank basically, so basically the tank would not flow, the water would not go out of the tank, or the tank would be completely empty where there's no more water.
Because we are working at level control. So in this case, I take a level of 80%. So maybe this is the best operation.
Interesting. Very interesting. Yeah, that's actually something very interesting because for me, like I never understood like how come the water is. I know that there's water coming constantly. I like it. It's logic, but how come the water is not overflowing? How come the pressure is not changing? I did not know that this is how it's done. That's very nice.
Yeah, so this level control is working in the background.
Yeah,
You never notice as a normal
normal person living in the house using the pipe. Yeah, okay, that's very nice. Thank you so much, Thomas.
Welcome.
It was very informative, and I can't wait to do this again with you.